Good morning to everyone tuning in live. Good morning to those on the East Coast of the US, and good day to everyone from around the world, no matter what time it is for you. My name is Josh Epstein. I'm the Chief Marketing Officer at Aris, and it's my pleasure to be moderating this panel discussion today. This is actually part of a series we're doing called Pulling the Digital Thread, where we explore trending topics and technologies shaping digital engineering, digital manufacturing, product lifecycle management, and the broader digital enterprise, really all from the perspective of this connected data and information that comprises the modern notion of a digital thread. So our goal is to bring together independent thinkers to exchange ideas and opinions and hopefully have some fun. We're streaming on a little bit of a delay today just to make sure we get some high quality audio. So while we won't be answering questions live, we do encourage you to participate by posting questions in the chat, and we'll bring those over into LinkedIn. Even better if you can go right into LinkedIn. Please use the hashtag pulling the digital thread in your posts, and that'll allow everyone to kind of coordinate. And please feel free to comment on anything you hear here, or pose your own ideas. I know the panelists are all on LinkedIn and will be participating as well after the panel. So this discussion is recorded, available all on demand after the event. So let's dig in. Today, I'm pleased to be joined by a few of the most influential thinkers in this space. We're really going to be delving into this idea of digital thread for large asset-intensive industries, asset-intensive applications. And so we're joined by Guy Brissell, Philippe Gautreau, Dr. Philip Roofing, Greg Pata, and Jason Casper. So just as a quick intro, I'll ask everyone to just tell us a little bit about their organization, their interest. I'll start with you, Guy. Guy, you're, I know, based in Seattle. You're Director of Business Strategy within the Manufacturing and Mobility industry team at Microsoft. Could you tell us a little bit about your role at Microsoft and how Microsoft supports its larger industrial customer base with application and software infrastructure?
Sure. Good morning. So I'm part of the worldwide manufacturing and mobility industry team. I'm one of the four-pillar solution leads. My focus area is really around everything to do with digital engineering, from PLM, digital thread, connected products, digital twins, the whole kind of end-to-end spectrum around digital engineering. So my responsibility is working with our customers and partners to ensure that we're bringing the right solutions with the right technologies to really deliver value for our customers.
Great. Excited to have you here. Philippe, let's turn to you. You are based in Lyon, France. You're the managing director of Accenture's Industry X practice. So, Philippe, could you tell us a little bit about Industry X for those that have not heard of it, and talk about how you support these large asset-intensive industries, both through the engineering and construction, so the EP side of the house, as well as into the owner-operator space?
Good morning, Josh. So I'm part of Accenture Industry X, and Industry X helps companies to reimagine the product they make and how they make them. So by combining data, digital, and AI from design and engineering to construction, manufacturing, service, return and renewal, our clients can be more resilient, cost efficient, sustainable, and can create new products, services, and infrastructure for their customers. Asset incentive industries companies are focused not only on build product, but also on operations. So they grapple with ensuring the durability, performance, and sustainability of their industrial assets. They face off a lot of different challenges like aging, improper maintenance, climate factors, and regularity demands. And Accenture can offer tailored industrial asset management solutions from strategy to implementation, from organizational design to processes, including people and technology. But nothing changes if people don't. So Accenture is uniquely positioned to help leaders transform their organization by focusing on the human science of change to encourage new mindset and behaviors, activate new ways of working, and unlock workforce potential.
Excellent. Thanks for joining us. Philip, I'm really excited to have someone who's really hands-on in the space. So Philip's head of offshore systems design for Amprion. Amprion is one of four transmission system operators in Germany. providing really power to the entire country. So carry electricity for over 29 million people. Philip, could you give us a little perspective on Amprion? I don't think probably most of our listeners are necessarily familiar with Amprion, but about your role there and your interest in digital transformation in the space.
Yeah, thank you very much. So at Amprion, our role is to bring power to the people, and this expands in Germany. So as you said, we are one of four, but this expands from the North Sea to the Alps in the end. And here, our job is it to bring the power to our 29 million people, secure a stable grid operation, and also paving the way to climate neutrality. So to pave the change of the energy system, and that means a lot of expansion of the grid. So really large scale projects, and also within Europe to provide projects which are connecting Germany with other nationalities, but also integrating the entire offshore wind space to shore. So here, these are quite some changes in the grid, very large scale projects. And that's exactly where we come in from the system design perspective, to make sure that, especially from the electrical part, but not just the electrical part, it's always a connection for these kind of projects between and the electrical part and your offshore platforms, which are massive, to make sure that everything is working well. And so there to oversee this system design aspect and plan, but also execute these kind of large scale projects properly. That's more or less our task in the system design department.
Excellent. Really happy to have your perspective here. Greg leads Aviva's engineering portfolio team, driving product strategy for the engineering business. Prior to Aviva, he ran his own digital transformation consulting business with lots of experience managing oil and gas projects, from multi-billion-dollar thermal heavy oil projects to smaller sustaining capital brownfield projects. Greg, super excited to have you here. Can you tell us really about some of your work at Aviva, building solutions for digital thread and asset lifecycle management?
Yeah, thanks, Josh. So, yeah, a little bit about Aviva. I guess we are probably one of the bigger industrial software companies out there, striving to be the biggest, I think. And data has always been at the heart of what Aviva's been about. If you look at the entire part of our all of our different business areas, we really focus on how do you bring data together across an entire asset or facility or a business to try to make better decisions, higher optimized operations, and how to engineer better. And so that's my area in particular, is the engineering side of things. So really it starts with that part, from where I'm sitting, and we really focus on bringing that digital asset to life with data-centric tools, with the vision that that's what becomes the cornerstone of a digital twin, and you start establishing those digital threads right at the beginning of when you're conceiving a project, and you want to keep that persistent all the way through operations, and that means really providing a view all the way through how that first process engineer thought about what might go into a plant to how your operations guys optimize it and get the best performance out of it, and being consistent the way that data is managed all the way through the life cycle is sort of core to our philosophy at Aviva.
Excellent. Thanks for being here. And finally, Jason Casper. Jason has the privilege or the curse of having the office next door to me, so he's my go-to person to answer all things digital thread. He's been with Aris 7 years as Senior Director of Product Marketing. Prior to Aris, he spent many years focused on asset lifecycle management and asset performance at companies like Aspen Tech and GE Digital, as well as industry analyst at LNS Research. Jason, could you kind of give us the perspective on Aris, how Aris thinks about these larger asset intensive industries, and really how PLM thinking can be applied to these larger, more complex engineered systems?
Yeah, sure, Josh. So like when we're thinking asset or capital intensive industries, it could really span the gamut, whether that's oil and gas, onshore, offshore, refining, chemical or other process related industries, pharmaceutical, CPG. You have mining, power gen, and power transmission distribution. Um, all of these industries have a common problem. There's sort of a simultaneous proliferation of information being created at all times, but it also seems to be very disconnected and siloed. And where we're seeing this problem start typically is throughout the development of greenfield or brownfield projects during the engineering, procurement, and construction phase. And so for us, over the last few years, we've been seeing clients who are building and operating these complex assets starting to explore a product lifecycle approach. Um, this PLM approach has been used primarily in discrete manufacturing industries. And now they're looking to see how they can apply some of those techniques not to just manage a single product or a host of product offerings, but a system of products, or as these asset intensive businesses call it, a system of assets during all phases of its life cycle: design, build, operate, and maintain. And there's now an opportunity for companies to transform using the digital thread to start thinking about how they connect systems, suppliers, contractors, and customers while managing, and this is the crux of the problem, the incredible velocity of the design and configuration change that happens with these complex products. So, projects. So, to do this right, using a platform approach opens doors to more collaboration, faster collaboration, compliance, and then ultimately, when done correctly, there's what our customers are looking to do, which is that how do I syndicate this data I now have that's traceable, it's connected, and share it with stakeholders across operation, maintenance, and even now like the upgrade phases of legacy plants. And so really for me, being here today is thinking about our platform, but then the panelist perspective on how we bring this all together.
Awesome. Well, listen, I think we have a lot of things we can talk about. Let's provide a little bit of orientation to the discussion. Greg, let's start with you. Just maybe start by answering the basic question of how is the notion of digital thread, connected data, connected information, collaboration, transforming the way that organizations think about this sort of engineering and design in this space.
Yeah, well, it's I think everybody talks about it in their various ways of working as silos, right? Is information ends up getting held in different places, and it makes it really hard for other people to access that information once it's in that silo. And engineering and design projects are exactly like that. They have that problem in spades, and traditionally getting information from one part of a team to another part of the team, just so they can even actually implement the project, let alone hand it over to an operations team, is really problematic. And a lot of it, if you look back into sort of the processes that folks have gone through, it's because it's very document centric. They like to turn PNID into a PDF and hand it off to the next guy, who then takes that data and extracts the information they want to turn it into a line list or a data sheet to go buy something. And that just keeps going all the way through the entire project lifecycle into operations, and to terrible state where I've been on projects where you literally have hundreds of binders of documents that get handed over at the end to an operator, who then has to go make sense of these things in order to operate a facility. You layer on top of that, well, that facility is going to look like that for all of about a minute before somebody starts making the first change to it. And then they can't remember why they did it the way they did it. And so there's all the requirements behind it. And then if somebody wanted to go duplicate that, they've got no idea exactly where to start from either. And so all of this value that got created during the design phase gets lost. And then you can't figure out how to optimize. You don't know, there's just so much information that we could have readily available to the people that are going to be running and operating plants. And even between folks on a project that are helping try to develop that project in the first place. It could just be so much easier if we focused on the data instead of documents. And when you look at things like just an object, a pump, or something like that that's part of a project, you can follow the lifespan of that thing all the way through, how it got defined in the early stages to how it got procured, how it got installed, how it got checked, how it got commissioned, and eventually how it got operated and maintained. It's all about that one pump. And then you just put the rest of the pieces around that. It's all around those other pieces too. So, keeping that as sort of something, the thing I like to think about is, if you think about it as data, is now you can pivot it into all sorts of different views. So you can suddenly think about that information the way you need to do your job, whether it's part of a project team or into operations. And, the big thing that we're seeing is the challenge around that in the data world is, how do you keep track of when are you actually turning this from data that you're thinking about to data that you're working with? So who brokers, how do you keep track of when do I publish effectively the equivalent of publishing that data into something that somebody else needs to consume and use? And in particular, in process industries, that becomes really important when people's health and safety are at stake. Or in other places where there's sustainability things that we're trying to achieve, how do you check to see what the emissions are, or the embedded carbon of a facility is going to be? So you don't want to make mistakes. So that publishing function is really, really important. So, there's 100 reasons why you want to have things from a data perspective, but one of the challenging things to do is keep track of why and when is certain things, when a certain view is going to be accepted as the view that everybody works from at a certain point. And that's where one of the biggest challenges we've seen out there in industry in terms of adoption. That's the document allows you to have that view. As cumbersome as it is, that's what people like to gravitate to. So moving towards that digital thread, you need to break away through that and come through. And that's, I think, why this sort of product lifecycle or asset lifecycle type approach is going to be so important to maintaining a digital twin, because the documents aren't doing it either. They're too slow. They get out of date. So now you got to keep the data up to date. So you need to have some sort of brokering service that really, really manages all that and knows why and how and when things have changed in a facility. So you can really manage around how it's being operated and maintained. And if you're going to, even worse, if you're going to go make some changes to that facility, what's already there, so you know what changes you're actually going to anticipate, so you can create a new future state of that plant.
That's fascinating. And did a nice job, I think, of describing the complexity. I mean, you can say it's easy to say going from documents to data, right? But when you actually think about the what a document represents as sort of like a source of truth, right? How do you actually move that into a free flowing kind of where data can flow, but you can still have that official record, that decision to publish. I'm curious from the rest of the panel, and Philip, in particular, I'm always going to go to you to say, okay, in the real world, like how does this actually work, right? But I'm curious perspective on this documented data challenge. How do others perceive it?
So I can completely relate to Greg's view or views. So we face a lot of challenges in regard to the amount of large-scale projects which we have to execute, and executing them at the same time. Also bringing lessons learned back, because the projects, the life cycles are so long. Just project execution is 7 years. So bringing the information back to the next project and knowing exactly in which project which component has which state. It's a very important information, and it's very important for bringing people together, for bringing knowledge together, for being flexible in terms of decisions during execution, and to be also internally being transparent about your decisions, so that you can, as Greg just said, later on exactly know why did we take a certain path down the road, and what implication did it have. Or does it have maybe also for the future? So these kinds of challenges are very important for us, and there is exactly the sweet spot where we say, okay, inspirations from starting with requirements engineering, going to let's say components of the entire PLM thinking, to take them into consideration and to move forward from having just based on history, or on our history, having a limited number of large-scale projects operate or in execution in parallel. And in the future, we will have a vast amount of large-scale projects which are operated in parallel. And maybe one last idea for this part, also for people, for our employees, it's very important, because the world is just a little bit faster than it used to be, I guess. And once you need a certain expert in another project, it's very important to have all this information, all this knowledge, how it has been designed throughout and decisions have been made throughout the project. So to have this strong foundation, that is also something where I think this will strongly help us to improve the ways how we work and not having these silos, not just in terms of fields, like technical fields, but also silos in regard to project A, project B, project C in one company.
Yeah. Philippe, I'm curious. So you've probably got more than anyone the perspective on how this is done at multiple different organizations, and obviously, Greg talked about sort of set up the how difficult this is or how complex it is. But stepping back, what are the fundamental challenges or barriers to implementing a digital thread in these types of industries? Obviously, it's sort of a new way of thinking. Philip said the world is moving faster and faster. How is this? What are the big challenges that folks are needing to overcome?
Yeah, fully aligned with Greg and Philip. So we can imagine four kind of challenges. The first one is related to the energy transition at the same time with aging facilities. Okay, energy transition forced this company to go quickly in terms of managing a large amount of portfolio project and so on in a short time frame. And at the same time, they have to support aging facilities with sometimes a very limited access to operational data. The second challenges are more related to operations. So in order to optimize their operations, they have to deal with a lot of different kind of information and data. They have also to deal with frequent breakdowns. Maintenance is performed after failure, and it implies high emergency repair and MRO other delays. Third challenges are more related to what we call the digital maturity. A lot of companies are, let's say, document-centric, and they have to move to data-centric. And it's a big move sometimes, And so there is no single source of truth. There is no data governance in place. Sometimes we have a limited data availability and quality in disparate systems result inconsistent asset health data. And most of the time, we have inconsistency between physical assets and engineering data. And the fourth challenge are more related to people. So there is, as we have heard, there is a lack of cross-functional alignment between operations and maintenance. So there is no evidence of well-defined trainings program inside this kind of company. And skills are often supported by people with poor documentation and poor traceability. So there is a big risk when those people are leaving the company. So this is the kind of challenge we have to face.
Any perspective, Guy? I'm curious from you probably also have a view of how lots of different organizations globally are thinking about this, and I assume Microsoft. One of the number one sort of consumers of power and this need to kind of build more power is actually AI and data centers that obviously Microsoft has an interest in kind of enabling. I'm just curious from the Microsoft perspective, how do you think about this transition? How do you think about helping organizations overcome these challenges, maybe from an infrastructure level?
Mm-hmm. Yeah, so the first thing I'd say is kind of interesting from you think of AI energy consumption. We've got a very aggressive sustainability strategy with our data centers, which is going to see us get to this kind of net zero goal in the future. And there's a number of areas I'd say. I've been talking to many customers over the last year, 18 months. I mean, very early last year we had the breakout of generative AI, and we went into this phase where a first horizon of what I like to call, looking at the wall of wonder. It's like, okay, many companies are looking at, hey, what can we do? What's the benefit? How do we approach this? And now we're very much past that and into this next phase. And I thought there was some very kind of poignant areas that Greg mentioned that really kind of stood out. So if we think across our four pillars, the types of challenges that our customers are facing, around product design needed to shorten the overall kind of design cycle, move away from physical prototyping, through to the factory, the skills gap. As Greg mentioned, all of the siloed data and systems that that are very prevalent into supply chain. That level of complexity, risk, all the way through customer experience. And there's every day, expectations from customers continue to rise continually, and that opens up so many opportunities. From moving towards what we'd maybe call more autonomous development, things like knowledge discovery, generative design, connected products, the integration of IoT with engineering. Um, the whole co-pilots world. If you think about the skills gap and the AI kind of factory co-pilot approach, field service was another great example. Moving into production monitoring, I think, which is a really good one. Optimization, predictive maintenance, quality, all the way through supply chain, how you're managing that risk, sustainability, thinking about the carbon footprint, energy cost optimization. The list just goes on. But there's probably I would say two or three cases that uh, I'll double click into, which I thought were really kind of prevalent. I mean, just based on what Greg mentioned. So the fact that siloed, we've got so much siloed data. We're seeing a lot of customers, not just thinking about migrating PLM to cloud, but also they have many different instances dotted around the globe, which hinders collaboration. Um, so it's not just that migration, but also that kind of consolidation that's happening now. And really, if you're going to take advantage of some of the newer increasing AI capabilities, one of the key things that you need here is your data. Um, and it was really interesting. Greg mentioned about the PNIDs and PFDs, and I've been working with several customers around. They're like, "Hey, we've got these binders full of these schematics, and or we've got PDFs." And generative AI is kind of opening up a really interesting, value proposition of how do you extract and how do you bring some of the insights and knowledge out of those paper schematics or those kind of 2D PDFs that you've got of those schematics, and using that to really move into the whole kind of digitalization and digital transformation. And to help in some of these, the last point I'll make is when we're thinking about manufacturers needing that kind of trusted data foundation for really enabling transformation at scale. We recently announced the manufacturing data solutions at the Hanover Messe event, and that was, I think, a real kind of watershed where we're thinking about from a digital thread perspective. We're thinking about how we can help unify data, contextualize data, and kind of start to democratize insights to from that data. And this is all built on some of the services that we've recently released around Microsoft Fabric, for example. So I think it's truly what I would call an exciting time, as we've moved past this. Hey, what can we do? We're over that wall, and now we're into the I think the transitional phase of hey, let's really get some value and leverage the technology to deliver that value.
So I'd love to turn it back to Philip, and again keep us real. Like, how are we getting value today? How does digital thread? And obviously, we're still early in this journey, but I think we're making some progress, and certainly it sounds like Amprian's leading the way in thinking. But how does the digital thread, with AI or just even our just basic good old human intelligence with better data, how is it improving decision making? How is it actually making the world a better, safer, more productive place?
Just by long term having the data and having it when you need it. I think is a very important part. So let's imagine we take a decision today to move from, I don't know, one pump type to another, and then years later, people in operation, the component fails, and you don't have all this information why you choose a certain technology. It's just lost, and this happens so fast. It's stored on somewhere, some kind of SharePoint. People are happy with it, and then at a certain point in time, it moves somewhere in the digital nirvana, and that's exactly where these kind of solutions will help us long term on a long term scale, being, let's say, the true master of our data. And that's why also now it's important to collect it, to have a very strong path on how you track your data, so that it's all, as you said, this single source of truth, to have it all at one place, so that later on during operation or late project stage, I don't know, that you can really tap into that knowledge you obtained years before. And the same goes for designing, for example, another project. I want to have the information from one project and take it into let's say considerations for the next project, and that's not an easy task because projects, large scale projects, they are very um, strong. So they have strong organizations. They need to have it. They need to move quickly. So it's a challenge for these projects also to do a proper documentation so that what you do is also relevant for the next project and so on and so forth. So also there, having this single source of truth where you can store these kinds of decisions, these kind of design bases, change requests, whatsoever, all having this at one place makes it just so much more liberating for any other, in this case, any other engineer, but this counts for everyone in a project, to say, okay, no problem. I have the information regarding this pump through all different projects which we executed.
Thanks. Maybe let's do a quick around. Guy sort of broached the AI subject, but let's maybe go around to everyone. Philip, starting with you, where do you think AI in say the next couple years? Where is the biggest opportunity to apply to apply AI?
That's a good question. Like there are a lot of fields where we could use it. It always is or comes very much down to how strong the decision or how strong the information are which you have generated by the AI. But let's imagine, for example, you have a contract which is about clauses and requirements on support about if you printed thousands of pages. To really quickly know what is in there and to get based on a certain request, a very fast answer on this, how information and how clauses and requirements, how they intertwine. That is something where generative AI can support us very well if it's at the right, let's say, stage of development. And also for quick check, for example, it's a lot of work to always check that certain requirements which you always have regarding documentation, but also regarding is something meeting your requirements. Also there, I think there are a lot of opportunities how to use AI. The question is always how strong can we rely on it? And I think that is the strong lesson, or these are the lessons we need to learn in the next years, and to always test it out and be at the, let's say, forefront, to have this technology on hand where we can use it, and also have someone challenging it to make sure that we are taking the right decisions for these large scale projects.
Greg, I'm curious from the Aviva perspective. Obviously, lots of lots of opportunity. Lots of Aviva helps people manage massive amounts of data. How do you think about AI and where it can be applied?
Well, yeah, the question, where aren't we thinking about AI? So, I mean, there's so many layers to it. It gets kind of meta because you're using AI on top of AI on top of AI. But, we start off looking just for design assistance, right? How do you make it faster and easier, based on best practices or rules to implement? So you kind of take the best designs and sort of easily replicate them, or be able to transition, say, from a schematic into a 3D model as quickly as possible, so that you can get to a financial investment decision, or just even help the skills gap, right? As the aging, experienced guys move out of the business, you need a faster way sometimes to accomplish the same things you used to be able to do. So those are the easy ones. The more interesting ones that I think we're seeing is around the universal translator type functions in the LLM world. Is you forget how much, when you're specialized in a certain area of a business, how much you talk the way you talk, and nobody else can understand you. And one of the really interesting things about the LLM world is that it helps bring that together. Is when you want to understand data or something that's going on in the way you think about it, now you can easily do that with the way that you ask questions, the way you can interrogate that information. So that's one other thing that we're really seeing with sort of intelligent data access through sort of natural language. The other one I'll mention real quickly is validation. So the biggest concern that, well, the reality is adoption of a data-centric approach and going down this digital thread thing is always going to be a challenge if you don't trust the data you've got. It's the old problem. If your sat nav gets out of date, are you going to keep using it? Probably not, right? So how do you make sure that the data that you're working with is actually up to date and accurate? And that's where we see a lot of the AI potential being there to help with either validating data to make sure it's accurate, comparing against laser scans or other, later information. And there's a lot of stuff that you can do on that front to really help with that validation of that data to keep it up to date. Because if you can't, I mean, again, that's another part of this whole brokering process. Again, it gets very meta here, but yeah, you really do need to stay on top of your data, and I think AI is going to play a huge role in making sure that it keeps in sync.
No, excellent. Philippe, I know AI and data strategies are a big piece of the industry X practice at Accenture. Where do you see the biggest opportunity to apply AI in the relatively near term?
I think we had a very good list of already. We can share a lot of Accenture AI skills, use cases. But what I can see is the one focused on the be more reactive to predictive using data simulation, procedure digitalization on top of that AI, of course. One other use case we can have is providing better to support to people using chatbot using AI. And I have a recent one, which is the how you manage the handover between the requirements that you have in manage and your installation and with supplier. And we are using AI to manage the consistency between all the requirements you have to deal, different kind of requirements. It can be technical requirements, regulatory, cyber security requirements, and the way you distribute these requirements to different suppliers. And AI can be very helpful to manage this consistency.
Oh, fascinating. Fascinating. Yeah, I know we're just scratching the surface on what it can do, and it's going to be exciting time to actually see how it is employed in the field. Jason, maybe you could talk a little bit about we've talked a lot about digital thread, but obviously digital twin, digital thread. Can you summarize how Aris thinks about the relationship between digital twins and digital threads?
Sure. I think the short answer is one doesn't exist without the other. You need these two working in concert to generate the value. And what I think about are customers that are working to create viable digital threads across the life cycle that ultimately are transforming their business model. So Philippe at Amprion, right? I heard you say it starts with requirements, and we're seeing other customers have that same belief. If you can centralize those requirements, standardize what those requirements are, it becomes repeatable for the next project. And anytime that you can create repeatable content, you're saving time for the next project. Um, and so our customers are looking at it beyond the collection of data to creating the context with the data, which ultimately supports AI strategies. Um, but what this connected digital thread does is allow you to create new applications, collaborate, um, comply with evolving regulations, and then ultimately allows you to create that syndication of information. So, how do you do that? That's bringing together all this information and potentially an easy to use interface, which enter the digital twin. Digital twins by use case for a digital twin at handover, a digital twin for specific assets in the plant, that give you not just the picture, but the complete story of each asset or the plant itself. I've heard throughout this conversation the story of the valve, and through my history with working with maintenance software, that was always the example used of, is it the valve or is it the design of the plant? It's, engineering is saying maintenance, it's your fault. You don't have an effective maintenance strategy. Maintenance says, well, I keep fixing it. It keeps breaking. There's a problem backward. They could never trace that backward um, information enough to have a valued conversation, maybe change the strategy at the plant. And so that digital twin becomes that capability to communicate throughout the organization. And so, at Eris, I think that's where we see the combination of bringing together all this data, the managing it so you have the context of what is the right information, and then using that to maintain that digital twin as it moves through life, right? Because it's not just a static story, it's going to continue to evolve. And so being able to manage the configuration changes of the asset itself, so the digital twin is always current and contains the history, is going to be a huge step forward for these capital intensive businesses.
Excellent. I mean, you brought up the subject of handover. Obviously, thoughts in general about that. What does the digitalization of handover look like? Right? How is that really going to transform the way that assets are, sort of transferred? Is it going to become easier? Is it going to be more continuous? Like, what does the team think? It's just sort of out. Whoever wants to jump in.
I can jump in. So we kind of talk always about a progressive handover. So the one thing about breaking down those silos, especially when you're at the early stages, is an engineer thinks he knows what an operator wants, but an operator really knows what he wants. So why not make it available to him, right? Why not let the constructors who have to decide how are they going to put this thing together, and the operators who are going to have to operate see that information as it's being built, and allow them and give them the opportunity to critique it and give advice and sort of get a better design to start with, more constructible, better operable, more operable. And so that progressive handover is really, really important from that perspective. But also, if it is what you want to build, then you can start to build training simulators in that, and you can train folks to be ready to operate that plant even before it's built. And then you can get the nameplate as fast as possible, because that's ultimately what every project wants, is to get up to speed as quickly as possible. Not only just get a good efficient plant, but get to nameplate or full capacity with little barriers, because that's really meeting the business case. So to me, that data-centric handover is a huge enabler for more efficient operations and faster startup.
Well put. Well put. Hard to believe, but I think we're kind of reaching the end of our session here. So would really encourage everyone out there to please continue the conversation online, so you can use that hashtag pulling the digital thread. I know the team here will be watching, and would love to sort of get the broader community's perspective on what we're talking about here and continue the discussion. So thanks everyone for your time. Now immediately following the webinar, you'll be linked to a survey. Really would appreciate the feedback. Philippe, Philip, Guy, Greg, Jason, really great discussion. Thanks for the perspective. Hope we can do this again. Thanks very much.
Thank you.
Thank you.
Yeah, thanks
Thank you very
everyone.
much.